Okay, solving permutations and combinations in word problems. Okay, first question. How many outfits can you make if you have 5 shirts, 7 pants, and 10 pairs of shoes? Assume that you need a pair of pants and shoes and a shirt to make an outfit. Okay, so on these ones you just say that you have 5 choices for shirts, 7 for pants, and 10 for shoes. So therefore there's 350 outfits possible. Okay, what are the odds of winning the lotto? So to win a lotto, you need to pick 6 of the correct numbers, and there's 49 numbers to pick from. So the order of those numbers doesn't matter, you just have to have them. So therefore it's a combination. So 49, choose 6 of the numbers. This is going to be a big one. So there's that many possible combinations of 6 numbers. So almost 14 million. So they do advertise it as 1 in 14 million. So your odds are 1 in 13,983,816. Okay, there are 7 boys and 5 girls. How many committees of 4 can you make? If there are A, no restrictions. So if there's no restrictions, then you have 10 people and you're making a committee of 4 people. So 10, choose 4, or sorry, not 10, 12, choose 4. Is 495. Okay, what if you have to pick 3 boys and 1 girl? So if you pick 3 boys, you have 7 boys to choose 3, and girls, you have 5 girls to choose 1. Okay, so 7 choose 3 is 35, 5 choose 1 is 5. So the answer to that is 175. Okay, how many committees if you have to pick at least 2 boys? Okay, so we're going to go at least 2 boys. You can have 2 boys. You could have had 3 boys, or you could have had 4 boys then. Okay, so the probability, the possible combinations if you have 2 boys would be 7 choose 2, therefore you're doing 5 choose 2 girls. If you had 3 boys, you'd have 7 choose 3 and 5 choose 1. And if you had 4 boys, you would have 7 choose 4, 5 choose 0, which is 1. Okay, so we already did this number, 175. 7 choose 2 times 5 choose 2 comes out to 210, and 7 choose 4 is 35, and again that's just 1. So if you add those together, it's 420. Okay, another way you could have done it is you could have said if there was 1 boy, then your odds would, or your combinations would have been 7 choose 1 and 5 choose 3. So that's 70. And if you had no boys, then you would have had 7 choose 0 and 5 choose 4. So that's 1 and that's 5. Okay. Then you could have taken 495, subtract those, and you would have got 420 as well. Okay, so the at least part you could subtract the underneath part. Okay, what if Alex or Kristen are the committee but not both? Okay, so we have to figure out when Alex is on the committee. So if Alex is on the committee, then and Kristen is off. Okay, so if Alex is on, then you have choose one for him. And then for the rest, now you have 12, and you can't use Kristen, so you only have 10 left to choose 3 people. Okay, and then if Kristen is on and Alex off, so if Kristen is on, that's your choose one person, and then you only have 10 people left to choose 3 more because you can't pick Alex. Okay. So this is 120. And another 120, so that's 240. Okay. How many arrangements can you make using the letters Mississippi? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So 11 factorial ways to arrange those letters. But you have to consider that if you use an I and then another I, right, that's the same thing. They're going to be repeated. So the repeats are 1, 2, 3, 4 repeats of I. S gets repeated, 1, 2, 3, 4. And P gets repeated twice. So you're going to divide by the repeats. Okay, so when we calculate this, it comes out to 34,650 arrangements. Okay, how many ways can you seat 5 girls and 5 boys if there's no restrictions? Okay, if no restrictions, then you have 10 P10, or the same thing would be 10 factorial. So that means there's a lot of arrangements, just over 3 million. Okay, what if you had to alternate boys and girls? Okay, so if you were alternating boys and girls, the first spot you could put 10 people, you had 10 choices, but on the second time, since if you used a boy, then you would only have 5 girls to pick from. If you used a girl, then you'd have 5 boys to pick from. Okay, so then if you'd used a boy here, now there'd be only 4 boys left to pick there, and this was girls, so now you only have 4 girls, and etc. Okay, so in other words, if you want the shorthand, you do 5 factorial times another factorial, 5 factorial, but you double it because then there's 2 choices in the first blank. So 5 factorial times 5 factorial, and then double, so 28,800. If Andrew and Zach sit beside each other, so you have to treat them like a unit. So they're 1 unit. So now you only have 9 units that you can arrange, but then within that unit you can flip-flop Andrew and Zach around. Okay, does that make sense? So 9 factorial times 2. Andrew, Zach, and Toby sit together, so they're 1 unit. So now you only have 8 units to move around, but then between Andrew, Zach, and Toby, the 3 of them could rearrange themselves within that group 3 factorial. So that's 241920. Okay, what if they sit in couples? So if they're in couples, then you actually only have 5 units. Okay? But within this unit, they can rearrange themselves 2 different ways. 2 different ways, 2 different ways, 2 different ways. So each unit can arrange themselves in 2 different ways. So that makes 3,840 ways.